Hello and welcome to another TA Tech Tip. In this Tech Tip video, we will learn how to calibrate the heat flow of the Q600 before using it for standard experiments. The STT heat flow calibration is based on two runs, one with empty pans and other using a sapphire disc provided in your STT kit. Begin the test by placing the empty pans as close to the beams as possible. In this case, we are using alumina pans. In the instrument control software, set the mode to STT Calibration and select the test type as DSC heat flow. Enter the sample name, select the pan type as alumina and enter the weights as 0. Select the procedure tab. Enter the details based on your subsequent experimental conditions. Set the post-test conditions. Click play. Wait for the experiment to finish and allow the STT to cool to room temperature before starting the next experiment. The second run of the heat flow calibration is identical to the previous run, except that the sample pan contains the sapphire disc. Enter the sample information and the weight of the sapphire disc. Enter the reference weight as 0. Select the same temperature range and heating rate as the previous run. Hit play. At the end of both runs, select Calibrate, Analyze, DSC Heat Flow. Select the appropriate files. Right-click on the screen and select Analyze. You can either drag the cursors or right-click on the screen and enter the temperature limits manually. Once the temperature limits have been entered, right-click on the screen and select Limits OK. Right-click on the screen again and select Analyze, Accept Results. A further refinement to the heat flow calibration can be performed by calibrating the cell constant based on the heat of fusion of a known standard like zinc. To begin this calibration, tear two empty alumina pans. Place the zinc sample in the sample pan, load the pans onto the beams and close the furnace. On the instrument control software, click on Calibration, Cell Temperature Table. Set the cell constant as 1. Change the mode to standard mode. Change the test procedure to ramp. Enter the sample information. Click on the procedure tab. The recommended start temperature is at least 100 degrees centigrade below the theoretical melting point, and the recommended final temperature is at least 50 degrees centigrade above the theoretical melting point. The heating rate should be the same as that being used for subsequent experiments. In this example, we will use 20 degrees C per minute. Click on Apply and play. Once the experiment is completed, open the data file in Universal Analysis. Integrate the melting endotherm using Analyze Peak Integration Linear Baseline function. Mark the temperature limits. Calculate the heat of fusion. Dividing the theoretical heat of fusion for zinc by this measured value gives you the cell constant. Return to the instrument control program and select Cell Temperature Table from the Calibrate menu. Enter the calculated value of the cell constant in the cell constant field. In this tech tip video, we have outlined the necessary steps to calibrate the heat flow of the Q600. Please stay tuned for more tech tip videos from TA Instruments. Thank you for your interest.